Hi students, today we are going to solve problem number 17. A uniformly charged conducting sphere of 2.4 meter diameter has a surface charge density of 80 microcoulomb per meter square. So it is 80 is plus 80, so it must be positively charged. Subdivision A, find the charge on the sphere, and subdivision B, what is the total electric flux leaving the surface of the sphere. Now the shape of the conductor is spherical and its diameter is 2.4 meter. Therefore radius of the sphere, so radius R must be equal to 2.4 divided by 2. So this must be equal to 1.2 meter. So we need the radius of the sphere. Secondly, surface charge density, that is charge density. What do you mean by charge density? First of all, that is equal to what? The total charge on the sphere. Total charge, how much coulomb is distributed on the sphere, divided by surface area. So divided by the surface area of the sphere. The symbol which we have used for charge density is sigma, and sigma is equal to the charge on the sphere Q divided by the total surface area of the sphere. Total surface area of the sphere is 4 pi r square. 4 pi into r square. So what is given in the sum is this surface charge density sigma is given. So sigma is equal to 80 microcoulomb per meter square. Microcoulomb means 10 power minus 6. Okay, so coulomb per meter square. Sigma is given and the surface area A is equal to 4 pi into r square. Okay, so this is now equal to 4 into 3.14 into r square, 1.2 the whole square. So this is 1.2 the whole square. And what is asked here? What is the charge on the sphere Q? Q is asked. This is the first part of the problem. So we have a formula sigma equal to Q divided by 4 pi r square. So Q is asked now. So what must be Q equal to now? Sigma into 4 pi r square. Is it not? So Q must be equal to sigma into 4 pi r square. So this is equal to value of sigma is to be substituted. It is 80 into 10 power minus 6 or 8 into 10 power minus 5. So this also may be written as 8 into 10 power minus 5. Okay, one 0 can be adjusted here. So I will write sigma is 8 into 10 to the power of minus 5 into 4 pi. So this is 4 into 3.14 into 1.2 the whole square. So this calculation we are supposed to do, is it not that? So we will take now, the calculation is to be done. So 4 into 3.14, 4 into 3.14. So this is now equal to 12.56. So this is 8 into 10 power minus 5 into 12.56 into, this is 12 are, okay, 12 square is 144. So this must be 1.44. Now I am going to multiply all of these. Okay, so 8 multiplied by 8 into 12.56 into 1.44. So the value is coming like 1.44. It is coming as 1.45. So this product is coming as 1.45 into 10 to the power of minus 3 is coming. So what must be the unit for the charge? Charge is in coulomb. Therefore, charge Q is equal to 1.45 into 10 to the power of minus 3 coulomb. You can also write this minus 3 coulomb as millicoulomb. Okay. That's also permitted. So the first part of this problem has an answer. Q is equal to 1.45 into 10 power minus 3 coulomb. Okay, students? Okay, how do you approach the second part of the problem? Now, these are all positive charges and hence there will be a flux. Flux will be passing perpendicular to the surface area on all sides like this. So, these are the electric flux lines which are penetrating through the surface area. So, which law is relating the total charge on the sphere or enclosed by the sphere? Though the charges are spread on the outer surface of the sphere, it is equivalent to as if they are concentrated at the center of the sphere. Is it not? So, now the surface charge density, from that we have calculated the charge present on the outer surface. Now from that we have to find the electric flux passing through the surface by using Gauss law. Understand? So from Gauss law. So we will remember then and there what principle or law is used also. So we are using the Gauss law. The total flux of the electric field, that is denoted by phi E. This is equal to 1 by epsilon naught times the total charge which is enclosed by the sphere. So in the denominator there is a term epsilon naught, that is called permittivity of free space. Now I am going to multiply the numerator as well as the denominator by 4 pi, so that I can write this also is equal to 1 divided by 4 pi epsilon naught into 4 pi into Q. I have adjusted this 4 pi because we know the standard value of 1 by 4 pi epsilon naught. Instead of dividing this charge by 8.854 into 10 power minus powers, we can better multiply by 9 into 10 power 9. That will be a better always. Multiplication is easier than division. That is why. So this is now equal to 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9 into 4 pi already we have found it is 12.56. So this is into 12.56 into the charge. The charge is 1.45 into 10 power minus 3. So this is 1.45 into 10 to the power of minus 3. So now I am going to multiply. Okay. So we have to find out the product now. So 9 into 12.56. 9 into 12.56 multiplied by 1.45 multiplied by 1.45 is equal to 163. So this is 163.91 into here 10 power plus 9 and minus 3 will make it as what? 10 power 6. So this is 10 power 6. Therefore the electric flux is phi E is equal to, now instead of writing 163.91 into 10 power 6, if you want you can write this as 1.6391 into 10 power 8. Okay, or we can round this off. We can round this off as 1.64 into 10 to the power of 8. So this is Newton meter square per coulomb. So this is the answer for the second part of the problem, the total flux using Gauss law. So here we have first used the definition of surface charge density. Surface charge density is the ratio of the total charge on the sphere divided by the total surface area of the sphere. Okay. Then in the second step we have used Gauss law. The total flux of the electric field passing through a closed surface is equal to 1 by epsilon naught times the net charge enclosed inside the sphere or on the sphere. I hope you must have understood well. Fine.